All right, we are almost to the end of Module D. The last thing that we want to talk about is graphing quadratic equations. In this section, we're going to look at quadratic equations in standard form. Okay, so let's go ahead and start with what is standard form. Standard form is going to be an equation of the form y equals ax squared plus bx plus c. Now we have some review material and we're going to have some new things that we're going to find when we talk about graphing quadratic equations. So the first thing that we have is direction. This is going to be similar to slope. Recall that slope determined whether a line went up or down and whether it was a steep line or a shallow line. We have the same thing here, or something similar to it here. We have direction. So just to start off with, what is it we're going to be graphing? We're going to be graphing something called a parabola. And the two that we're going to look at is we are going to look at if a parabola that opens up or a parabola that opens down. The shape of this is going to be something like a curvy V. So what do we have here for direction? If A is positive, then the graph opens up. It'll have this basic shape. If A is negative, then the graph opens down and it looks something like this. Okay, some other things that we have. We have Y-intercept. Recall when we talked about linear equations, the y-intercept is where the graph crosses the y-axis. In order to find the y-intercept, we want to plug in 0 for x and simplify. We also have X-intercepts. X-intercepts, this is where the graph crosses the x-axis. We want to plug in 0 for y and solve using factoring if possible. If it does not factor, then you have one of two conditions. Either you have no x-intercepts, or you don't have nice x-intercepts. In either way, we don't want to graph those. Okay? Okay, so those are some concepts that we should be fairly familiar with. We have some new things that are special to quadratic equations. The first is the vertex. The vertex is the maximum or minimum point on the graph. If the graph opens up, it is a minimum and it's the bottom point. If the graph opens down, then the point is on the top and we call it a maximum. Now when you're working on your homework, be very careful because sometimes they will ask for a maximum or minimum point, which you will have both x and y, you will have the vertex. They may also ask for a maximum or minimum value, and in that case, you only list the y coordinate. Okay, so how do we find the vertex? Let's go through that. So the vertex, we want to plug into our vertex formula. And so what is our vertex formula? This actually comes from our quadratic formula. We're going to use the outside of the quadratic formula to find the x-coordinate of the vertex. The outside of the quadratic formula is going to be negative b over 2a. Now this just gives us an x-coordinate. We still need to find a y-coordinate. So to find the y-coordinate, we're going to plug the result into the original equation. Something else that we have is called the axis of symmetry. Symmetry means that you have mirror images. And so what we're going to do is we are going to draw a line through our parabola. It's going to go through the vertex. And it basically cuts our graph in half. Depending on how accurate your graph is, you should have mirror images on both sides. What that means is that as you move the same direction from the vertex on the left and right, your y values should be the same. We'll explore that in a little bit more detail. The other thing to notice is that this is a vertical line, And recall that vertical lines are always of the form x equals something. And what is x equal to? Well, it's equal to the x-coordinate of the vertex. Now, when we talked about linear equations, we said that we need a minimum of 2 points in order to graph it. For quadratic equations, you need 3. You need the vertex, and you need 2 symmetric points. So what do I mean by symmetric points? You need to have points on both sides of the vertex in order to get your correct shape. Okay? All right, so let's go ahead and look at some examples. Let's look at example B. Example B, we have y equals x squared minus 6x plus 8. The first thing that I note, and this is just, as I said, a check step, is my direction is it's going to be opening up. So we should have something that looks like this. The reason this is opening up is because that is a positive x squared term. Okay, so now we need to actually get down to our computations. The first thing I want to find is my y-intercept. In order to find my y-intercept, remember that intercept always means something's equal to 0. Since we're looking for the y-intercept, I want to plug in 0 for x and simplify. If we do this, we get y equals 0 squared minus 6 times 0 plus 8. My first two terms equal 0, and so what I have is y equals 8. So my y-intercept in point form is 0, 8. The next thing we want is the x-intercept, or intercepts. Since it is an intercept, remember that we want to plug in 0 for something. Since we are looking for x-intercepts, I want to plug in 0 for y and solve for x using factoring. You could also use quadratic equation, but that's a lot of work for something like this. So let's see what we can get here. If we plug in 0, we get x and x. Things that multiply to 8 is 4 and 2. If we look at that, we have positive 8. They have same signs. In order to combine numbers that have same signs, we want to add to a 6, and we want them to be the same as the negative. So we get x minus 4 and x minus 2. I can set both of these equal to 0. And solve each equation, giving me x equals 4 and x equals 2. So my x-intercepts are going in point form will be 4, 0 and 2, 0. The last thing that we need is the vertex. So the vertex, we can go ahead and plug in our numbers, our coefficients, into the formula x equals negative b over 2a. If we plug that in, we get minus a negative 6 over 2 times 1. This is equal to 6 over 2, which gives me 3. I want to take that and plug it back into my original equation. And if we plug it back into the original equation, we get 3 squared minus 6 times 3 plus 8. If you simplify this, you should get y equals negative 1. So remember that x equals 3, y equals -1 is your vertex. If you struggle to remember the vertex formula, if you can find your x-intercepts, then your vertex is going to be halfway between 2 and 4, or 3, because a parabola, as I said, is symmetric. So it should have this nice shape to it where your y values are going to be the same on either side. Okay, so let's go ahead and graph what we have here. We have a y-intercept of 0, 8. My graph isn't quite big enough for that, so I'm going to have to add in a couple more tick marks. We have x-intercepts of 2, 0 and 4, 0. And we have a vertex of 3, -1. If you notice here, the left side, I have more points on the left side than I do on the right side. And so, even though it's okay, you may want to add in another one. Notice that I don't have to compute anything new. Notice that if I go 3 to the left of the vertex, I am at +8. So that means that if I go 3 to the right of the vertex, I should also be at +8. We now have enough points here not only to give us the parabola and have everything we need, but also to have a nice shape that hopefully will look good once I finish drawing it. Nope, nope. Okay, that's not, well, it's not the worst one I've ever drawn. This is what our picture should look like. We should go ahead and label our points, label our key points. We have 4, 0 and 2, 0 as x-intercepts. We have -3, 1 as a vertex, and we have 0, 8 as our y-intercept. The last thing that we want to include is our axis of symmetry. And so our axis of symmetry is going to be a line that cuts this graph in half. And it's going to go through x equals the x-coordinate of the vertex. So we get our axis of symmetry is x equals -3. All right, so what does that look like on our graph? I'm going to use a dashed line in order to represent it. And if you look at this, now we can see that we have symmetry around our axis of symmetry. All right, let's go ahead and look at another example. We have the equation y equals x² minus 6x plus 4. So the first thing that I'm going to do is start with my direction. So does this open up or down? Since this is a positive x², this will open up. The next thing we have is the y-intercept. If I plug in 0 for x, I get 0² minus 6 times 0 plus 4. My x terms cancel, and we're just left with y equals 4. So my y-intercept is 0, 4. Okay, what about x-intercepts? If we plug in 0 for y, we get 0 equals x² minus 6x plus 4. This does not factor. So since it does not factor, we're going to go ahead and just leave it alone for now. Okay, what about our vertex? If we plug into our vertex formula, we get x equals negative b over 2a. So this becomes minus negative 6 becomes positive 6 over 2 times 1 equals 3. All right, if we go ahead and plug this back into our original formula or our original equation, we get 3 squared minus 6 times 3 plus 4. If we simplify this, we get 9 minus 18 plus 4, which gives us negative 5. So our vertex is 3, negative 5. Okay, so let's go ahead and graph what we have so far. 0, 4, this is going to be up on the y-axis. 3, negative 5 will be 3 to the right and 5 down. Now, we do have an issue here. We only have 2 points here, and so I need to find a third one. So, the first thing before we begin, I'm going to talk about my axis of symmetry. Recall that the axis of symmetry is going to go through your vertex. It's going to be x equals our x coordinate of the vertex, 3. Okay, so now how are we going to use this to find another point? So what we're going to do is, if you look here, if we look at the vertex, to get to the y-intercept, I go 3 to the left, and I have a y-coordinate of 4. So we want to do the same thing on the right. We want to go 3 to the right. If we go 3 to the right, we should also have a y-coordinate of 4. And so this point, if you go ahead and calculate it out, my symmetric point is going to be 6, 4. We go 1, 2, 3, 4, 5, 6 to the right and 4 up. We now have enough to graph this. It's going to look something, hopefully a little better than that. Let's go ahead and label our points. We have our y-intercept is 0, 4. Our vertex is 3, negative 5. Our symmetric point is 6, 4. And our axis of symmetry is x equals 3. All right, so that takes care of that one. All right, next example, we have y equals x squared plus 6x plus 5. So let's go ahead and start with direction. We have that this is a positive x squared, so this is going to be opening up. All right, for our y-intercept, if we plug in 0 for x, we get 0 squared plus 6 times 0 plus 5. Our x terms cancel, leaving me with just y equals 5. So our y-intercept is 0, 5. Okay, let's look at our x-intercepts. For x-intercepts, remember we plug in 0 for the other variable, so we're going to plug in 0 for y. We get 0 equals x squared plus 6x plus 5. And if we go ahead and factor this, we get x squared is x and x. 5 is 1 and 5. We have to multiply to a positive 5, we have same signs, and to combine to a positive 6, they are both positive. Alright, if we set each factor equal to 0 and solve, we can subtract 1 on the first one. We get x equals negative 1. And on the second one, we get x plus 5 equals 0. We can subtract 5 on both sides, and we get x equals negative 5. So our x-intercepts are negative 1, 0, and negative 5, 0. Okay, vertex. We're going to use the equation x equals negative b over 2a. B is our second term, so we're going to use negative 6 over 2 times a is the coefficient of x squared. We get 1. And if we go ahead and simplify this, we get negative 6 over 2 or negative 3. Alright, that's our x coordinate. So now our y coordinate. We get y equals negative 3 squared plus 6 times negative 3 plus 5. Simplify this, we get negative 3 squared is positive 9. 6 times negative 3 is negative 18 plus 5. And if we simplify this, we get negative 5. So our vertex in point form is negative 3, comma, negative 5. Our axis of symmetry is going to be a vertical line, so it's going to be x equals, and our x coordinate of the vertex is negative 3, so it will be x equals negative 3. The last thing that we want is a symmetric point, but we'll go ahead and find this after we start graphing. Okay, so let's go ahead and graph this. We get 0, 5 for our y-intercept, negative 1, 0, and negative 5, 0 for our x-intercepts, and negative 3, negative 5 for our vertex. So for our symmetric point, we're going to go symmetric to the y-intercept. So here we have, if we move 3 to the right of the vertex, we're at 0, 5. So I want to do the same thing on the left. If we move 3 to the left, we're also going to be at negative 5. So our symmetric point is going to be negative 6, comma 5. Alright, if we go ahead and graph this now, we should get something that hopefully looks better than this. We want to go ahead and graph our axis of symmetry. Our axis of symmetry cuts our graph like that. And now let's go ahead and label our key points. So we have -6, 5, 0, 5, -5, 0, -1, 0. Our vertex is -3, -5, and our axis of symmetry is x equals -3. All right, last example. Let's see here. Let's go ahead and start with direction. Since we have a minus x squared on this one, this is going to open down. We have our y-intercept. Our y-intercept, if we plug in 0 for x, we get -0 squared, minus 2 times 0, -3. My x terms cancel, leaving me with y equals -3. So my y-intercept is 0, -3. All right, for our x-intercepts, we'll plug in 0 for y. We get -x squared, -2x, -3. I'm going to factor out a negative. We're going to change all the signs of the terms, and we get x squared plus 2x plus 3. Now we do want to be careful because if we look at this, this actually does not factor. We have a +3 here, and in order to multiply to a +3, we want numbers with same signs, but there is nothing that multiplies to a +3 and combines to a +2. So this doesn't factor. Okay, let's go ahead and look at vertex. We get x equals -b/2a. If we plug in, we get -2 becomes +2 over 2 times -1. This is 2 over -2 or -1. If we plug in, we get y equals -1 squared minus 2 times -1 minus 3. -1 squared is +1, but we still have the -1 in front, so this is going to be -1. -2 times -1 is +2 minus 3. And if we go ahead and simplify this, we get -2. So our vertex is -1, -2. Our axis of symmetry, this is going to be a vertical line through the vertex, so it's going to be x equals -1. And right now we are going to need a symmetric point. We do not have enough to graph this in order to get the shape. Remember that we do need to have points on either side of the vertex. Okay, let's go ahead and graph what we have so far. We have 0, -3 for our y-intercept. We have -1, -2. And if I find a symmetric point, note that we have 1 to the left of the vertex. We are going down to -3. So 1 to the right of our vertex, we will also be at -3. Now that we have our symmetric point, we can go ahead and graph. The coordinates for the symmetric point are 2, -3. We want our axis of symmetry. And then we want to go ahead and label. So we have 0, -3. We have 1, -2. And we have 2, -3. All right, so that takes care of graphing using key points.